In our first few example problems, what we want to do is use these basic trig identities that we discussed on the first page to simplify each of the following problems to a single trig function or number. Now, eventually, we will have a target in mind where you actually know what the answer is, and it's just your job to prove that the given expression equals the final result. But here, I'm not telling you what the answer is, and we're just going to use basic trig identities to simplify this to a single trig function or a number. And so if we look at letter A, we have sine of theta times the cotangent of theta. And so what I'm going to think about doing here is using a trig identity to express cotangent of theta in terms of sine and cosine. And so if you think back to your identities, hopefully you have them in front of you somewhere so that you can see them as we're getting going here. We remember that cotangent of theta can be rewritten as cosine of theta divided by sine of theta using a quotient identity. Then that will be multiplied by the sine of theta. What we recognize next is that we have a sine of theta here and a sine of theta in the denominator here, and so those are going to cancel out, and so the final result is that this will just simplify to the cosine of theta, which is much simpler than what we started with. If we look at letter B, again, we have sine squared theta over cosine theta, this time multiplied by cosecant of theta. And again, sort of what I want to do here is to get things in terms of sine and cosine if I can. And so what I recognize is that I have this cosecant of theta right here, and I can rewrite that in terms of sine theta because that is the reciprocal of cosecant. And so just copying down sine squared theta over cosine theta and then multiplying cosecant theta, but rewriting that as 1 over the sine of theta using a reciprocal identity. What we recognize then is that we have a sine squared of theta in the numerator and a sine of theta in the denominator. And so you can really think of this sort of in different terms as like x squared over y times 1 over x. In that case, you would see, okay, I can reduce the x here with one of the x's here. And so we're going to do the exact same process right here. And so the sine theta here will reduce with one of the sine thetas up here. And so what that's going to give us then in the numerator is sine of theta times 1, which is just sine of theta, divided by cosine of theta times 1, which is just cosine of theta. And then sine of theta divided by cosine theta, hopefully you're recognizing that as tangent theta, which is that quotient identity. And so this will reduce nicely to just tangent of theta, which is our single trig function or number that we're looking for in these problems.